Hello and welcome to my submission for CT5108, Boids. In this scene I have a group of Boids with flocking behaviours that can be changed during runtime using these three weights here. As you can see, I have a separation weight, cohesion weight and an alignment weight. Increasing the separation weight will make the Boids spread out from each other. Increasing the cohesion weight will make them all come together. As you can see, they form these little groups. And increasing the alignment weight means that they all go in similar direction to everyone surrounding them. Alignment works by calculating the average velocity of a group of agents. It then applies the velocity to the current Boid. Cohesion works by calculating the average location of a group of agents. It then tries to seek towards this location. And separation is very similar, but it flees away from the average location of a group of agents. Each Boid contains an array of Boids that are close to it. It does this by calculating every other frame using a function in the Boid manager. It loops through each Boid and checks the distance. If the distance is less than the set neighbour radius, it will return it and add it to the array. All of the weightings are added to the target velocity in update. Alignment has priority over everything, then cohesion and then separation. It also adds a wonder if the target velocity size is less than 1. It will then calculate the force and set the location of the Boid. It will also set the rotation based on the velocity. Each Boid also has obstacle avoidance. If it's going to come into contact with an object, it will attempt to steer around it. This is done by performing a raycast and then fleeing away from the result location. You can also edit the size of the boundary that contains the Boids. If you make it smaller, they will all be contained into a smaller area, and if it's larger, they can spread out more. You can also tick whether to draw the boundary wireframe or not. You can also change the spawn count, and pressing respawn Boids will clear all the Boids on the scene and instantiate a bunch more based on how many you've put the spawn count to. The widget blueprint is very simple. It just has functions that can change the value or call the function on the Boid manager. For instance, it can change the separation weight. And it can also call a function to spawn the Boids and destroy the Boids. The spawn Boids function in the Boid manager just clears the array of Boids and then spawns a new Boid with a random location and rotation. It then adds it to the current array of Boids. On the ground below all the pigeons is a cat that is wandering around. You will also notice that there is a breadcrumb slider. This makes it so that pigeons will leave the flock more often. As you will see, there is a pigeon descending right now. When the pigeons land, the cat will try and chase them. If the cat gets close enough, the pigeons will fly away and return to the flock. If there are no pigeons directly near the cat, but there are within a certain distance, the cat will try to go to the average location of all the pigeons. The cat's wonder function is very simple. It will just calculate a random location. It will then seek to that location, and if it's close enough to the location, it will get a new one. It will also stop the cat from going too far. The pursue function will calculate where the pigeon is going to be. It does this by getting the location and adding the current velocity. It will then try and seek to where it thinks the pigeon will be. The cat has a reference to all the Boids from the manager. It can check whether it's within a certain distance, and it will then start to pursue the pigeon. If it's close enough, it will make the pigeon return to the flock. If it's not that close, but it is within another certain distance, it will cohesion to the general location of where all the pigeons are. If not, it will just wander around. And here all the force is calculated and the location and rotation is set. The blueprint function for the pigeons leaving the flock has a delay with a random seconds which is affected by the breadcrumb count. If the breadcrumb count is lower, then it will take longer for Boids to separate. It then picks a random Boid, checks whether it's already eating. If it is, it will loop back to the start. If it's not eating, it will make the Boid leave the flock. It will then add it to the array of floor Boids. The pigeon ground wandering function is identical to the cat's. There is also a tick box which allows you to make the birds fly around the city. They will fly around in a loop constantly while the tick box is ticked. This is done in a blueprint function which will loop constantly and check whether the tick box is ticked. If it does, it will set a delay and it will move the Boid manager. It will then increment through the loop. You can also press this button to reset the boundaries position, so you don't have to wait for it to loop around again. I've also added a very simple optimization called intermittent thinking. Essentially what this does, it updates half the Boids on opposing frames. So the first half of the Boids will be updated on one frame, and the second half will be on the next frame. This is done for a very simple for loop. This line here is just checking whether it is an odd number of Boids, so that one Boid doesn't get missed out. There was another optimization I attempted, where instead of each Boid looping through every single Boid every frame, it would instead do a sphere overlap, so that it would only get the Boids closest to it. This ended up being a lot slower, as you would need to enable collisions, which introduced a lot of lag.